At any point, have you gazed toward the night sky and contemplated whether there are more urban communities out there, loaded with lights like our own? Envision this. The James Webb Space Telescope has recently made a momentous disclosure that could turn this dream into reality. This isn't simply another space story, it's a discovery from 7 million miles away that could reclassify how we interpret life beyond Earth. Presently, space isn't just about stars and planets. It has its own form of city lights, and it's totally captivating. So, if you're amped up for this exciting disclosure and want to find out who is lighting those lights, then adhere to the furthest limit of the video and enjoy the mysterious story. The James Webb Space Telescope is now revealing secrets that challenge all we thought we knew. This telescope isn't just a replacement for the Hubble, it's a leap forward. It's equipped with the capacity to see long-wavelength visible light through mid-infrared frequencies. I found myself enthralled by a specific revelation from JWST, the exoplanet K2-18b, a heavenly body located 120 light-years away in the constellation Leo. What grabbed my attention is that this far-off world exists in the subtle habitable zone of its parent star. The general idea that far out in the distance, beyond the reaches of our imagination, lies a world where conditions may be perfect for life to thrive is completely phenomenal. As I delved into the details, my mind raced with questions. How does one even begin to comprehend the secrets of an exoplanet? The answer lies in the complex yet beautiful dance of light. Positioned as K2-18b orbits its parent star, the telescope examined the starlight passing through the exoplanet's atmosphere. Perhaps the universe itself paused, allowing us a fleeting glimpse into the secrets hidden within the gaseous veil of K2-18b. Researchers are getting truly excited about the small molecules they found during their investigation of space. One of these is a unique substance called dimethyl sulfide, DMS, which we frequently find on Earth as an indication of living things, particularly in the seas where tiny plants called phytoplankton thrive. Now, imagine how astonishing it would be if we found this same substance in the atmosphere of a distant planet called K2-18b. Did the observations from the Webb telescope show that DMS is there, suggesting that this far-off planet may be a good place for life? Indeed, Niku Madhusudhan, an astronomer from the University of Cambridge and the lead author of the groundbreaking paper, shakes us with the promise of confirmation. Upcoming Webb observations should be able to determine if DMS is present in the atmosphere of K2-18b at significant levels. Madhusudhan proclaims that the near-infrared imager, the slitless spectrograph, and the near-infrared spectrograph reveal that the spectra of K2-18b disclose a vast bed enriched with the hues of methane and carbon dioxide. Yet, it is the faint signal of dimethyl sulfide that sends our minds into overdrive. Beyond DMS, the astronomical journey yields more secrets. Carbon-bearing molecules paint a complex picture, hinting at the presence of methane and carbon dioxide, a hydrogen-rich atmosphere above, perhaps concealing a hidden ocean beneath. Imagine being on the surface of a distant planet called K2-18b, where the air is filled with whispers of various gases like dimethyl sulfide, methane, and carbon dioxide. This planet is much larger than Earth, with a radius 2.6 times greater, suggesting there may be a thick layer of ice beneath its surface due to the high pressure. Now we wonder, is it merely a coincidence that dimethyl sulfide is present on K2-18b, or does it tell us something significant about how life in the universe is connected? This question challenges how we might interpret space and our role in it. What do these gases tell us? Could they be telling the story of an entire ecosystem on this distant planet, thriving where we can't see it? Or do they suggest a sense of loneliness in the vastness of space, with K2-18b quietly observing the immense stretches beyond it? A while back, NASA's Spitzer Space Telescope discovered 7 rocky planets orbiting a distant star called TRAPPIST-1. Now, the James Webb Space Telescope is helping us learn more about one of these planets, TRAPPIST-1b. Using a special heat-detecting instrument, the telescope found that TRAPPIST-1b is extremely hot, like an oven set at 450 degrees Fahrenheit. But there's more going on that we're still unraveling. The Webb telescope has identified light emitted by an exoplanet as small and as cool as the rocky planets within our own solar system. Thomas Green, a NASA astrophysicist and the lead author of this cosmic adventure, notes that no previous telescope had the sensitivity needed to measure such faint mid-infrared light. Think back to when we first discovered the TRAPPIST-1 planets. There were 7 planets far away, comparable in size to Earth, and we were excited because they seemed like they could be great places for life. They were in the right zone around their star, where it's not too hot or too cold for water to be liquid. These planets gave us hope in the search for extraterrestrial life. But here's the intense part. These planets, like TRAPPIST-1b, are incredibly far away, around 235 trillion miles. Right now, we can't reach them. Framework rotates around a small star, more modest and redder than our own Sunday. As we contemplate the tremendousness of space, Green underlines the overflow of smaller, dwarfing sun-like stars by 10 times. Intriguingly, these smaller stars also boast a higher probability of facilitating rocky planets, making them practical objectives for space experts investigating potentially livable universes. These diminutive stars, notwithstanding their abundance, are not vast heavens waiting to be explored. They are known for their elevated activity, erupting and radiating high-energy beams that could pose a danger to emerging extraterrestrial life or the delicate environments of orbiting planets. The inestimable harmony between commitment and risk hangs in the heavenly ether. Tightly locked to its star, this alien world showcases a continuous expressive dance, one side perpetually lounging in the brilliant warmth of its sun while the other mulls in timeless night. Past observations of TRAPPIST-1b left a lingering question mark regarding its atmospheric composition. Might it boast a life-supporting atmosphere, or was it merely a forlorn rock suspended in the astronomical void? What do you think? Let's have a discussion in the comments. So, that's what simulation proposed. If an atmosphere enveloped TRAPPIST-1b, the temperature imbalance between its sunlit and dark sides would reduce the air like an inestimable guide, rearranging the intensity, directing the streams. However, the James Webb Space Telescope unveiled a stark reality, an unexpectedly higher temperature than anticipated. The absence of an atmosphere became glaringly obvious, eliminating another candidate from the list of potentially habitable worlds. Yet amidst the astronomical disclosures about TRAPPIST-1b's inhospitability, a different kind of energy persists. The real wonder lies not only in the nature of this alien domain but in the profound capabilities of the Webb telescope. Per-Olivier Lagige, one of the minds behind the instrument, discusses a dream, a desire to make a significant discovery, and it was this one he relished. For the first time, humanity witnesses the emissions from a rocky exoplanet, marking a crucial milestone in the ongoing journey of exoplanet discovery. Recently, while aboard NASA's James Webb Space Telescope, cosmologists made an unexpected revelation that adds another layer of mystery to the cosmic story. I find myself immersed in the energy of contemplating the puzzling glow of methane emissions around a brown dwarf, a celestial body often considered a failed star. Jackie Ferry, a cosmologist at the American Museum of Natural History in New York, enlightened us about the investigation of 12 brown dwarfs using Webb. Brown dwarfs, often referred to as failed stars, have greater masses than massive planets like Jupiter but fall short of achieving the nuclear fusion that ignites true stars. W1935, the brown dwarf in question, dwells 47 light-years from Earth, shrouded in the cold isolation of space. As Ferry's team delves into the mysteries of W1935, they encounter an unexpected twist while studying another brown dwarf, W2220, with a composition almost indistinguishable from W1935. They find the normal cooling of energy with altitude. However, W1935 warms at higher elevations, presenting a temperature reversal. In my mind, I picture Ferry and her team standing on the hill of the unexplored world, questions swirling like stardust in my imagination. What hidden forces are at play? Why does W1935 stray from the normal pattern? On the other side, Ben Birmingham, a lead modeler of the brown dwarf's computer simulation, expresses the confusion shared by the team. The temperature reversal observed in W1935 challenges the standard thinking that planets with nearby stars can exhibit such peculiarities due to external heat sources. However, W1935, in the absence of a clear heat source, leaves space experts without a clue. That is why cosmologists turn their gaze toward our celestial neighbors, Jupiter and Saturn. These gas giants boast their own auroras, much like Earth's northern and southern lights. I envision the charged particles colliding, producing bursts of light and heat. The cosmologists speculate about interstellar plasma or particles from a nearby active moon as alternative hypotheses. Auroras, as explained by NASA, occur when charged particles collide, creating a stunning display of light and heat in a planet's upper atmosphere. While astronomers have previously detected radio emissions from hotter brown dwarfs, W1935 stands out as the first cold auroral candidate outside our solar system, with the characteristic glow of methane emissions. Fairy comments with Webb. We can truly open the hood on the science and unload how comparative or different the auroral cycle might be past our nearby planet group. And here's where it gets serious. The Webb has recently identified lights from a human progress 7 trillion miles away that is WASP-96b, a planet that might be home to extraterrestrial life. Can you accept it? 7 trillion miles. An awesome distance. Difficulties all that we pondered our place in the universe. The telescope not just caught far-off lights, yet in addition uncovered expected indications of outsider life. Researchers are truly amped up for a new disclosure. It's making them reevaluate what they assumed they knew and making them very inquisitive about whether there may be life in different pieces of space. Presently, so many inquiries are jumping into my head. What does this discovery tell us about the universe? Are we the only ones here, or might there be other living things out there? The James Webb Telescope didn't simply see things. It started a tremendous interest and is causing us to reevaluate where we fit in among all the stars. I mean, who wouldn't be amped up for the thought of aliens throwing intergalactic parties? But here's the deal, it's not exactly obvious. I know aircraft. This TikTok video that is exploding with over 9.2 million perspectives is yelling, NASA just found city lights on another planet. It continues about the James Webb Telescope uncovering this pivotal discovery from a planet called WASP-96b, which apparently is 7 trillion miles away and may hold extraterrestrial life. It sounds like a science fiction blockbuster, doesn't it? Yet, as it turns out, WASP-96b is a genuine planet, just not the city lights sort of spot. It's about 1,150 light-years from us, and it's not precisely a comfortable objective. This planet, reported back in 2014, is a wreck with temperatures soaring above 1,000 degrees Fahrenheit. City lights? Not so much. Now, the James Webb Telescope is really astonishing, but it's not getting city lights. It's a star at identifying infrared light, which is beyond what our eyes can find in the visible range. NASA's not on an extraterrestrial metropolitan planning mission. Infrared light reveals new details and images, extending our comprehension of heavenly objects. So, rather than party lights on far-off planets, they're more like grandiose pieces of hints to the mysteries of the universe. The telescope has the skill for disclosing secrets tracing all the way back to the start of everything. The first stars, the earliest galaxies, and so on. As the starlight goes through the exoplanet's atmosphere and then through space, it arrives at the James Webb Telescope. The telescope has these fancy instruments called spectrographs that carry on like astronomical crystals. They separate the light into a rainbow of varieties, revealing the secrets of the planet's atmosphere. Now, here comes the cool part. Different atoms in the atmosphere absorb specific tones of light, like a customized diet for every molecule. If a certain tone is missing in the range observed by the Webb telescope, it means that the exoplanet's atmosphere grabbed that tone. It got absorbed. And guess what that implies? That atom is present in the planet's skies. The range of light caught by Webb showed that this hot Jupiter blocked light waves from water atoms, implying there's water hanging out in its thick cushion clouds. It's like getting a slip top into a far-off planet's atmospheric projection. Now, the James Webb Space Telescope isn't just here for beautiful pictures. Sure, the pictures are amazing, but the real magic lies in these spectra, the lines and tones that let us know what elements are messing about in these distant atmospheres. This discovery is no joking matter since it's a significant step in our journey to understand if there are planets out there that could be a piece like home. We've been scanning the skies for some time, and the James Webb Telescope is taking us to an entirely different level of investigation. As Webb races through space, it's not simply pursuing radiation from unbelievable distances, it's also going back to some time in the past. It catches light from the ancient past, uncovering the first systems, stars, and infinite designs that formed billions of years ago. Can you imagine seeing the introduction of the universe? The telescope's objectives go beyond our solar system. It intends to comprehend far-off universes, looking for indications of something going on under the surface in the environments of exoplanets, water, methane. These are the cosmic breadcrumbs that could lead us to extraterrestrial neighbors. Have you ever contemplated whether there's life beyond Earth? Webb doesn't simply notice, it has revamped our vast story. It has recently uncovered pictures of Stephan's quintet, a cosmic dance 290 million light-years away, where 5 galaxies gravitationally interact and crash, a huge artful dance frozen in time. Can you feel the gravitational pull of galaxies a large number of light-years apart? The telescope turns its gaze to the Carina Nebula, a divine material 7,600 light-years away, a heavenly nursery where stars more massive than our sun show signs of life, emissions, double stars, and vast precipices. The Carina Nebula holds the secrets of heavenly birth and advancement. However, the shocks don't end there. The JWST uncovers a second star in the southern ring cloud, a figure 8-shaped beauty, 2,500 light-years away, a dying star, gas, dust, and now a newly discovered companion. What other heavenly mysteries lie concealed in the immensity of space? And then there's SMACS 0723, a galaxy cluster 5 billion light-years away, a window to the early universe telling a story of galaxies evolving in the universe's childhood. What else might we discover in space? Will the Webb telescope show us additional astonishing things or uncover planets without any indications of something going on under the surface? Although space might not be the amazing place we thought, Webb's story, combined with its capabilities, keeps our interest alive. It pushes us to explore space even more. As we investigate space, we're eager to find new things and uncover secrets, taking us to places where we don't know what to expect. Now that the James Webb Space Telescope just detected these lights from way somewhere far away from here, 7 trillion miles from Earth, it appears we're finally getting a brief look at far-off neighborhoods in space. This amazing telescope allows us to peek into an entirely different part of the universe and wonder about what's going on far past our own planet. It's like tracking down gleaming stars that are really city lights in a place a whole lot farther away than we ever imagined. Isn't it mind-blowing to think about what's going on out there? If the thought of city lights 7 million miles away has knocked your socks off, remember to hit that like button and share this stunning revelation with your fellow space aficionados. Share your thoughts in the comments. Do you believe there could be a massive cityscape out there? Until next time, continue to explore the wonders of the universe.